Okay, in this video I'm going to be talking about the foundations of trigonometry, and aside from the Pythagorean theorem, which I'm going to assume that that you already know, the basic trigonometric functions form the foundation for trigonometry, of course. What we're going to be doing is we're going to be examining a right triangle, meaning a triangle with a one angle that is at 90 degrees. And you can see I'll color it here. This little triangle, or this little square at B, tells us that this is a right triangle. Okay, that's how we represent that, to say that this is 90 degrees. Okay. Basically what we have is we have A, B, and C, all capitals, representing the corners of the triangle. And sometimes people will represent the sides, and they'll say like A, B with a line over it or something like that to demonstrate that it's a line from A to B. Another convention that I like is to just label the sides A, B, and C as well. And the reason why that they're like this is that the side opposite to the angle is the lowercase version of that same angle. So this is capital A, and the side, if I were to draw a line across from it, this side would be A. Okay, so lowercase a, and then B would be here, and then C would be here, right? And that's how I get those lowercase letters there. Okay, with that said, let's take a look at some of the trigonometric ratios. Now the first ratio or property that I'm going to look at is one called tangent. But before we can do that, what we have to do is we have to look at, we have to find a way to label the sides of the triangle. And what we're going to do is we're going to look at this one, angle C. Okay, so C right here, and I'll underline it in orange here. Okay, so we're going to look at just C. Okay. So when we're talking about angle C, okay, what we do is we call this side A the adjacent side. Okay, this side lowercase c would be called the opposite side, and this side B would be called the hypotenuse. And there might be an E on the end of this, but I'm not sure. Anyways, the reason why this is called the adjacent side is adjacent means beside. Okay, so A is beside, this side A is beside angle C, and this lowercase c one is opposite of angle C. Okay, you would not consider the hypotenuse to be adjacent ever, because it's the longest side and it's always the hypotenuse, and that's how you can distinguish it. Okay, if we were talking about A, the hypotenuse would stay the same. Okay, this side would become the opposite side, and this side would become the adjacent side if we were talking about angle A. Okay, it doesn't really matter what angle we're talking about, so I'm just going to leave it how it was here. Okay, so the first property I'm going to talk about is called the tangent. Okay, and the tangent, okay, tangent is abbreviated as tan. Okay, is the opposite over the adjacent. Okay, so tan is equal to opposite over adjacent. And what that means is that if we have any triangle with these proportions, okay, any size of triangle with these proportions, if you had if you're looking at angle C, if you were to take the opposite over the adjacent side, what you would find is that you would always get the same ratio. Okay, so it wouldn't really matter if we took, let's see, if we took this triangle or if we took a congruent triangle. So if I drew a line here and used this line here or used this line here, okay, it wouldn't matter, because we would this angle, because these are all congruent triangles or similar triangles, this angle here would always still be the same angle C, and the proportion of the opposite to adjacent would always be the same. Okay, and this is actually a really, really useful property, and probably the most useful property in mathematics, or one of them anyways. Okay, so let's take a look at an example here, and I'm just going to go with a very simple, it's called a perfect triangle. And so let's take this side to be 4, and this side to be 3. This is actually what this triangle is when I drew it. So this side that we'll say is 3, and this side we'll say is 5. Okay, now I've already worked out this triangle, but and you'll have to trust me on this for now, but this angle here is 53.1 degrees. Okay, and this angle here is 36.9 degrees. Okay, now it doesn't really matter if we know these or not at first, because I'm just trying to demonstrate the concept anyways. So just follow along here. Okay, so what I can do is I can say that, well, the tangent of C, okay, big C, is equal to the ratio of A, okay, over, or sorry, the opposite, C, over adjacent to A. Okay, which is equal to the ratio of 4 over 3. Now this is called, I should mention, this is called a perfect triangle because basically all the sides end up being whole numbers, which works out really well for the Pythagorean theorem. There's very few triangles that actually work out really well like this. So this would become 9, this one is 16, and then this becomes 25, and 9 plus 16 is 25, and so it works out perfect for the Pythagorean theorem. Like I said, there's not a lot of these, but this is a very, very common one, and you'll see it used a lot in examples. Okay, so what I'm going to do is also, well, let's just finish working this out. Okay, so what I'd find is that tan C is equal to 1.333. Alright, now what this on its own doesn't really mean anything, but what it allows us to do is to calculate measurements for triangles that we wouldn't otherwise know. Okay, now if, for instance, we didn't know what this angle was, okay, if we didn't know that this is 53.1, what we could do is we could say tan C is equal to 4 over 3, which would be equal to 1.333 dot dot dot. Okay, and what we could then do is use the reverse operation called arctan. Okay, and it looks like this. Okay, so arctan of C is equal to 1.333, or arctan of 1.333 dot 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 is equal to C. Now this symbol is often available on a calculator, and it's usually if you press the second function button and then the tan button. So it's usually located on top of the tan button on most calculators. I would demonstrate this on the Windows calculator, but you can see the Windows calculator does not have that. Okay, this tan H, these are hyperbolic, tan, sine, and cos. These are not the reverse of them. Okay, so Windows calculator doesn't have that, so you'll just have to trust me, or you can work it out on your own calculator. Okay, and what I'll find is that if I took arctan of 1.333, so in my calculator I type 1.333, and I type secant tan, I get 53.1. Okay, now I get more decimals than that, and these are just approximations, so I can't really be sure that that's exactly 53.1 because it's not, but it's a good approximation. Okay, now if I did this for A, I would get the exact same thing, okay, where it would be opposite, which would be A over adjacent, which would then be C for angle A. Okay, and I would get not the same number, but I would get the same ratio, and it wouldn't matter what triangle I used. Okay. The other trig ratios, okay, in the same vein, are the sine, okay, often abbreviated as sin, okay, and the sine is the opposite over the hypotenuse. Okay, and cosine, often just abbreviated as cos, which is equal to adjacent over hypotenuse. Okay. A lot of people remember this using a phrase called SOHCAHTOA. I personally don't like this, but if it helps you to remember it, then go ahead. And basically it looks like this. SOHCAHTOA. Right? And what this means is that sine is opposite over hypotenuse. cosine is adjacent over hypotenuse, and t, or tangent, is opposite over adjacent. Okay, as I said, I personally don't really like that, but if it helps you learn it, then go ahead. Okay, there's actually, along with these, there's actually a few other ones. Okay, there's 3 other ones which are basically the inverse of those. Okay, and what those are is one called cotangent. Okay, often abbreviated as cot. Okay, or cotan sometimes. Okay, cot. And that's equal to the adjacent over the opposite. Okay, there's cosecant, okay, which is usually CSC. Okay, and the cosecant is the inverse of the sine ratio, so it's hypotenuse over opposite. And then there's one called a secant, abbreviated SEC, and it is the hypotenuse divided by the adjacent. Okay. Now, the ones that we're going to be working on in the next series of videos largely are not including these 3. Okay, they are largely so these 3 aren't nearly as important. Not until you get into a higher level of math. These ones, okay, are by far the most important ones. Okay, and what we're going to do is, so I'm just going to delete these other 3 for now. Okay, and I'm going to show you how we might be able to use this to solve a problem. Okay, so let's get rid of this here. Actually, I'll just get rid of the, I just want to get rid of the triangle. Okay, so let's say we're given another right triangle. Okay, so one that we didn't know anything about, okay, or very little about. If you don't know anything about the triangle, then you can't solve anything about it. Okay, but let's say we know a few things. Now, in order to solve the entire triangle, meaning to find out what all of the angles are and all of the side lengths are, is you have to at least know one angle and one side, or 2 sides, but you have to at least know one of the sides. Okay, so either 2 sides or one angle and one side. Okay, so let's say, for instance, I just happen to know that this angle here is, I don't know, 30 degrees. Okay, and it's a right triangle. Okay, because this wouldn't work unless it was. Okay, and I happen to know that this side length is 5. Okay, okay, and let's see what happens here. Actually, you know what? Let's actually draw this so it is, so I can actually approximate some of these things. So what I will do is I'm going to look on my scale here, my ruler across the top, and draw this so that this has a base of 3 units. Okay, and I'm going to make this 3 by 4. Okay, so going back to my approximating my 3 by 4 triangle. Okay, but let's say, for instance, all I knew was that this is 3. Okay, and we knew from before that this should be about 51 degrees or something like that. Let's just see here. Okay, 4 divided by 3, second tan, yeah, 53.1. Okay, so 53.1 degrees. Okay, and that's all I know about the triangle for now. What I can do is I can figure out the rest of the triangle by just using these trig ratios. Okay, so what I can do is I can say, well, I know that the tangent, and I'll call this of theta. Okay, so tan of theta is equal to, well, let's call it C. Tan C is equal to side C all over, so opposite over adjacent, which is 3. Okay, and so that is equal to tan of 53.1 degrees. Okay, so what I can do is I can work this equation out, and I can say that little c is equal to 3 times tan of 53.1 degrees. Okay, let's pull up the calculator. Okay, and if I say tan of 53.1, tan, okay, that's equal to 1.33, and then I say times 3, okay, and I get approximately 4. Okay, so I know that this is 4. Okay, now I could use the Pythagorean theorem to find the length of the hypotenuse, but I'm not going to. Instead, what I'm going to use is, I'm going to just call this h for hypotenuse. Okay, and what I will do then is I'll say that I'm going to use a cosine ratio. Okay, so that I know that I have the adjacent, I need the hypotenuse. Okay, so I know that cosine of 53.1 is equal to the adjacent, which is 3, divided by the hypotenuse over h. Okay, and then what I can do is I can resolve this equation to say that h is equal to 3 over cosine of 53.1 degrees. Okay, and then what I can do is, let's see, I'll pull up my calculator. Okay, so I'm going to say 3 divided by, in brackets, cos of 53.1 cos equals, and I get 4.9965, which is very close to 5. Okay, now the reason why I didn't get 5 exactly is because this angle originally is not actually 53.1, it's 53.1 something something, and that's why I'm not getting the exact values. Okay, but otherwise I would. Okay, and so you can see that I was able to get all 3 of the sides, and I know that this is a right angle, and so I need just one more angle, and I can use any of the other trig ratios to find it. Okay, so what I'm going to do is I will use sine, for instance. Okay, so what I can use is I can say sine of, we'll call this side A, sine of A is equal to the opposite, which is 3, over the hypotenuse, which is 5. Opposite over hype, which is 3 over 5, okay, which is 0.6. Okay, now what we would have to do is we'd have to say then the arc sine of 0.6 is equal to A. Okay, now as I said, the Windows calculator can't do that, so I'm going to have to do this with my handy-dandy scientific calculator that I have in my hand and you can't see. So you just have to trust me, or you can do it on your own as well, and that would be fine. Okay, and so I did it, and I found that A is equal to 36.9 degrees. Okay, so 36.9 degrees. Okay, now I can verify these independently by using the Pythagorean theorem. Okay, so for instance, to verify that the sides make sense for this, so what I could say is that using a Pythagorean theorem is that if it's a squared plus b squared is equal to c squared, where c squared is the hypotenuse, then I'd get 3 squared plus 4 squared is equal to 5 squared. Okay, and I get 9 plus 16 is equal to 25, and 25 is equal to 25. So this works out. Okay, also I know that all of the interior angles of a triangle have to add up to 180. Okay, so the sum of the angles, sorry, this means sum of, okay, the angles is equal to 180 degrees. Okay, and so I'm going to get 36.9 plus 53.1 plus 90 for the right angle, and I should get 180. Okay, and so let's see, so I got 36.9 plus 53.1 plus 90 is 180. Okay, so I can show that this triangle, I can verify that this triangle is correct. Okay, and this will work for pretty much any other triangle. And what these ratios allow you to do is they allow you to start with any either two sides or a side and one angle and resolve the whole rest of the triangle, which is immensely useful. Alright, anyways, that's this quick, long lesson in the basic trigonometric ratios. I hope this was helpful to you, and if you have any questions, once again, drop me a line or send me an email or throw a comment into the comment box. If you like these videos, please give me a thumbs up and subscribe to my channel. Thanks a lot.